Atomic structure. Chemistry is the science of how three tiny particles, the proton, the neutron, and the electron, came together in trillions of combinations to form everything in the known universe. Atoms are the fundamental unit of matter. They are made up of three types of subatomic particles: protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. Protons and neutrons are located in the nucleus at the center of an atom, while the electrons orbit around the nucleus. Let's take a quick look at an atom of carbon. Notice how these 6 protons and these 6 neutrons reside in the nucleus, while the electrons are shown in orbits surrounding the nucleus. The number of protons identifies the element. All carbon has 6 protons. However, there are possible variations in the number of electrons and neutrons. Isotopes are atoms with the same number of protons but different numbers of neutrons. Therefore, they are still the same element and behave the same way as any other atom of that element in chemical reactions. But they have different weights because they have different number of neutrons. Another possible variation to an atom is the number of electrons orbiting the nucleus. Ions are atoms that carry a positive charge or a negative charge because of a different number of electrons. Cations have a net positive charge, while anions have a net negative charge. It is difficult to show the exact location of an electron. This is because electrons have almost no mass and orbit the nucleus of an atom at incredible speeds. Therefore, their precise location at a given moment can't be determined. For this reason, electrons are often shown as a negatively charged cloud surrounding the nucleus. However, other diagrams show the electrons as existing in rings or orbitals. Orbitals are often used to illustrate the number of electrons at different energy states surrounding the nucleus. But how did we come to this concept of the atom? Let's start with Leucippus and Democritus's theory, which stated that material could be broken down into smaller pieces and that everything we saw was made up of these smaller pieces. They called these pieces atomos, meaning uncuttable or undivisible. However, Aristotle did not believe in the concept of atoms. He claimed that there was no smallest particle of matter, and that everything was made up of equal proportions of fire, air, earth, and water. Because Aristotle was the more famous philosopher, people accepted Aristotle's philosophy, and the theory of atoms went largely unchallenged for the next 2,000 years. In 1803, John Dalton proposed a theory in which he accurately described and predicted chemical behavior. His 4 postulates are still accepted today with a few modifications. Number 1, all elements are composed of tiny indivisible particles called atoms. Number 2, atoms of the same element are identical. The atoms of any element are different from those to any other element. Number 3, atoms of different elements can physically mix or can chemically combine in simple whole number ratios to form compounds. Number 4, chemical reactions occur when atoms are separated, joined, or rearranged. Later, in 1897, J.J. Thomson discovered that a stream of particles was being given off when a strong electrical current was passed through materials. Thomson discovered that the beam of particles could be deflected by electrically charged plates, positive particles to the negative plate, and negative particles to the positive plate. If the particle beam was being attracted to the positive plate and repelled by the negative plate, the particles would have to be negative. Thomson knew atoms were neutral. The universe couldn't work if atoms were negatively charged because everything would repel and nothing would bind. So this was the first evidence that atoms were made up of smaller pieces. Thomson called these negatively charged particles electrons. After finding electrons, the next step for Thomson was making an atomic model. He knew that there had to be a corresponding positive charge to make atoms neutral. He assumed that the larger part of the atom is a positive mass with electrons embedded in it. He described this model as a plum pudding. This was challenged in 1911 by Ernest Rutherford. Rutherford and his team directed a narrow beam of alpha particles, a type of positively charged radiation, at a very thin sheet of gold foil. He wanted to measure the angle of deflection to measure how much charge is being deflected per particle. He expected particles to go straight through and a little bit of deflection from a slight positive charge. However, some particles came straight back, repelling after they hit the positive charge head-on. Some particles had a slight deflection, and some had a massive deflection because the particles were close to the charge. His experiment completely disapproved Thomson's model of the atom. Positive charge wasn't spread out, it was concentrated. Rutherford therefore concluded that an atom was mostly empty space. All of the positive charge was concentrated in a small region at the center of an atom called the nucleus. He theorized the existence of a neutral particle to hold the positive charge in place, called the neutron. Neutrons have no charge and almost exactly the same mass as a neutron. Neutrons were later confirmed in 1932 by James Chadwick. His model consisted of the nucleus in the middle, consisting of protons and neutrons, and a cloud of electrons surrounding the nucleus. However, Rutherford's model did not accept the existence of energy levels among electrons and therefore could not explain the chemical properties of an atom. Bohr proposed that an electron is only found in specific circular paths or orbitals around the nucleus. Each orbital has a fixed amount of energy called an energy level. The energy levels are not equally spaced. The higher you go, the less space there is between levels, and therefore the less energy is required to move. This is how we got to our modern concept of what atomic structure looks like, and how we discovered the three subatomic particles: protons, neutrons, and electrons. Thank you for watching.